In this last video, we're going to look at some theorems about segments and angles. The first one is called the right angle congruence theorem, and it simply states all right angles are congruent. This should make sense because we know all right angles measure 90 degrees, that's what makes it a right angle, and we also know that two angles that have the same measure are congruent. So if two angles are both 90 degrees, then they have to be congruent. So that's the right angle congruence theorem. The next one is the congruent supplements theorem, and it just says if two angles are supplementary to the same angle, or two congruent angles, then they must be congruent. Here's what it means. If we look at our picture, we have angle 2, and it's shown to both be supplementary with angle 1 and angle 3. You can imagine if you push those together so that they were adjacent angles, they would form a straight line. They would be a linear pair. So, because angle 2 is supplementary to both angle 1 and 3, that means angle 1 and 3 both have to be congruent. This should make sense if we think about it. Let's say, for example, that angle 2's measure is 150 degrees. If angle 1 is supplementary, we know they have to add up to 180, so that means angle 1 has to be 30. And similarly, if angle 2 is supplementary to angle 3, angle 3 has to add up with 150 to be 180, so it would also have to be 30. And it doesn't matter what number we choose. I could change this to be 140, and that would mean that both of our angles, 1 and 3, both have to be 40 degrees. Or any angle, any value you assign to angle 2, angles 1 and 3 would have to be the same because they have to add up to be 180. That's what makes them supplementary. Similarly, the congruent complements theorem says if two angles are complementary to the same angle or two congruent angles, then they are congruent. Again, if angle 5 is complementary to both 4 and 6, 4 and 6 have to be congruent because angle 5 has to add up to be 90. Let's say angle 5 is 51 degrees. I just made this number up so it could change, and 4 and 6 are going to change accordingly. But if angle 5 was 51 degrees, we know angle 4 would have to be 39, so they add up to 90. Also, angle 6 would have to be 39, because the only number that adds with 51 to get 90 would be 39. So the congruent complements theorem and the congruent supplements theorem are very similar. They're just saying when you have two angles complementary or supplementary to the same angle, your two angles have to be congruent to each other. Here's an example of a proof of the congruent supplements theorem. So, we are given angle 1 and 2 are supplementary, and also angles 2 and 3 are supplementary. We know that because they are supplementary angles, we can say that they add up to 180 degrees. That's a definition of supplementary angles. So, step 2, we can just write the measure of angle 1 plus 2 and the measure of angle 3 plus 2 add up to 180. That's our definition of supplementary angles. The transitive property says because they're both equal to 180 degrees, then we can set these equal to each other. So the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 2. The reason we set those equal to each other is now we have the measure of angle 2 on both sides. We can subtract that and get rid of it, and we're just left with the measure of angle 1 equals the measure of angle 3. If we know that the measure of angle 1 equals the measure of angle 3, then we also know that angle 1 and 3 are congruent, because congruent angles are just two angles that have the same measure. So here's a proof of congruent supplements theorem. Remember we talked about the word theorem means it has a proof to it. Okay, our last two we have a postulate and a theorem we're going to look at. The next postulate is the linear pair postulate, and it says if two angles form a linear pair, then they are supplementary. This should make sense to us as we know that a linear pair forms a line. We said a linear pair are adjacent angles whose non-common sides form opposite rays. So angles 1 and 2 have the same vertex, and their non-common sides, I've tried to trace here, form opposite rays. They form a straight line. So remember, linear pair makes a line. We know a line of straight angles 180, so it would make sense that a linear pair is supplementary. And then vertical angles congruence theorem. I mentioned this before, had you start working to memorize, vertical angles are always congruent. But there's a theorem we could actually go about proving this to say we know that 1 and 4 are a linear pair, they add up to 180. We know 2 and 1 are a linear pair, they add up to 180. So we know that 2 and 4 have to be congruent. Similarly, 1 and 3 are also congruent. So these 5 theorems and 4 theorems and 1 postulate are things that are going to help you with proofs. But a lot of these, you'll notice, we can get to different ways. If you forget these theorems, it's not a huge deal because you can go about a long way to solve it. But I want to show you the value of these theorems and how they provide shortcuts sometimes. So we're going to look at 2 last proofs. The first proof is given to us on this slide here. This proof says angle AEB is a complement of angle BEC. Complement means they add up to 90 degrees. So we're going to start with our statement. Angle AEB is a complement of angle BEC, and that's our given. Oh, we should stop and look to see what is it we're trying to prove. In this case, we're trying to prove that the measure of angle AED is 90. So notice they tell us AEB is a complement of EBC. That means we eventually know that those two have to add up to 90. We want to show that this angle over here, AED, is also 90 degrees. That's what we're trying to get to. So we're going to start with, because angle AEB is the complement of angle BEC, we know that means that the measure of the 2 angles have to add up to 90 degrees. That's what complementary angles mean. And you'll notice our reason was the definition of complementary angles. Step 3. We talked about this. When we see 2 things add together to equal a third thing, we ought to be looking for, is it an angle addition or segment addition postulate? So in this example, AEC is this big angle over here. It's equal to the measure of, so there's AEC. It's equal to the measure of angle AEB plus the measure of angle BEC. That's these 2 angles here. So that is the segment addition postulate. That's going to be our reason. Oops, I said segment. Notice we should be talking about angles. That's the angle addition postulate. Also, I've noticed that I forgot to write what number 2 is equal to. We said the measure of angle AEB plus the measure of angle BEC is equal to 90. That's our definition of complementary angles. So you'll notice that step 2 and 3 both have AEB, the measure of angle AEB plus the measure of angle BEC in the statements, which means we can use the transitive property to set these 2 parts equal to each other. The measure of angle AEC is equal to 90 degrees. So transitive property, substitution property. We generally use substitution property if we're talking about equality. So that's why I chose substitution property of equality there. They're saying the same thing. You can either substitute numbers in, or transitive properties is kind of like connecting the bridge. Okay, step 5 tells us the definition of supplementary angles. Supplementary, we know, add up to 180. So if we look at our picture, we only have one line. So angle AED and angle AEC are going to add up to be 180 because they are supplementary angles. So now we're going to substitute. And so if we look at step 5, we have the measure of angle AED. I don't see anything yet that we know that equals. We have the measure of angle AEC. We just said in step 4 that that's 90. So we can rewrite this. So we have the measure of angle AED plus 90 degrees is equal to 180. Now if we look, we're looking, how do we get from step 6 to step 7? I see 90, but I also see 180 on this side of the equation. Maybe we recognize that 180 minus 90 is 90 degrees, and that would give us our equation if we subtracted 90 from both sides. So we have a property that says we're allowed to subtract from both sides so long as we do it on both sides of the equation. So notice we don't have to write that subtraction step into our proof. We just write the result. But I went ahead and wrote it there to show you, to help make sure everybody was following along. So now we've proved what we were looking to prove, that the measure of angle AED is 90 degrees. So of course we're going to start out our proof writing our given. The angle ACB and angle ACD are supplementary. Also angles EGF and ACD are supplementary. Now notice I just wrote that all as one step, and I wrote given. I had a little bit of space to write a whole lot, so I used up several lines, and I just drew a line to say, okay, all of this goes together, here's my one reason. Now I was talking about the power of these postulates and theorems we were looking at in this video. Here's an example. We could prove this by showing that ACB and ACD add up to 180 because they're supplementary. So do angles EGF and angle ACD, they add up to 180. We could set them equal to each other because they both add up to 180, subtract that they both have ACD in common, and then conclude that ACB is congruent to EGF. But that's a whole lot of work to do the same thing as if we just use the congruent supplements theorem. The congruent supplements theorem just says if two angles are supplementary to the same angle, then they must be congruent to each other. That's what we have here. Because angles ACB and angles EGF are both supplementary to angle ACD, they must be congruent. That is the congruent supplements theorem. So that's all we have to do to finish our proof. So not all proofs are two-step proofs, but occasionally you come across one that's kind of nice. Again, remember, for every proof you need to go step by step, giving a reason for each of your statements. In this case, we only needed the two statements because we have reasons that justify both of them, and it proves what we were asked to prove.